All right, guys. So in this video, we are going to talk about more about statistics, but now we are going to do picturing variation with graphs. So what we did this past week, we talked about data. What is a population? What is a sample? How do we acquire data? Why is it useful? And all that good stuff. Also, we talked about sampling. Um, so yeah, now we acquire our data, and if you remember very correctly from class, we said that there was two different types of variables, right? So we had variables, and there was two different types. There was numeric or numerical, and we also had categorical. Okay, so those were the two different types of variables that we said that they were. So what we're going to do in this video is kind of try to display the data because usually when we have numbers, like let's say I'm just making stuff up. So like let's say we had something that looked like this. Well, the best way to really look at this type of data is actually to display it some sort of way. We want to be able to visualize it. We're visual people. I like graphs, so let's go ahead and try to graph things. So what you're going to be seeing over and over is this word distribution, and I'm going to be using it a lot. So the distribution of a sample, how does the distribution look like? How does the data look like? So this is just a way, the distribution of a sample is just a way to organize data. Okay, and usually the ways that we usually organize data is sometimes with a table, with a formula, or with a graph. So that's what we're going to be looking at. So numerical data. Okay, so there's three different ways that we're going to talk about in this class about how we can go ahead and represent this data. And the first one is through dot plots. Now, dot plots aren't really useful. We kind of don't even, well, I don't think anyone uses them. I mean, if they're small data sets and it's a small sample, then yeah, but I mean, basically all you're going to do is just place a dot for each observation. So for each observation is represented by a dot. So here it was patient satisfaction, maybe at a particular clinic. So we can say that one person, I don't know what then maybe one was not very satisfied and five was very satisfied. Then in this case, we would just count the number of dots, and the number of dots here is five. So five people were very satisfied in terms of maybe service. So that's basically all that a dot plot really tells us. So not really useful. I mean, it's only useful for small data sets. So if you have really small data sets, then it's it's a good way to start off. So since this is an elementary statistics class, and we do want to kind of see how you can visualize it. So this is just one way that we can use it. But you're not really going to see it very often. But also, if you have a lot of different values, so like if you were measuring weight or heights, and you have a whole bunch of decimals, then it may not be really useful to do a dot plot just because there's so many variables and there's so not variables, there's so many observations. So a whole bunch of dots are going to be everywhere. So that's the first one. It's just a dot plot. You just basically take a dot and put it on each observation is represented by a dot. So that's the first one. So now we go into the next one, which is called a stem plot. Okay. And basically what a stem plot is, I'm going to go ahead and help you and just draw one for you. So basically the way that we just say, so let's take this number 46. So these numbers are just sample scores from a particular exam I gave a very long time ago. So I just randomly selected it. So this right number is what we're going to call the leaf. And this 4 is what we're going to call the stem. And usually the way that we do it is that the right numbers, right, are going to go on the left hand side. So in this case, if you look at all of our data, right, it goes, if you look at all of the first numbers, 4, 6, 7, 8, 9, that's going to go in here, right? So 4, and I'm going to go ahead and go in order, so don't skip numbers. So 4, 5, 6, 7, 8, 9, right? So that's what it looks like. And then what I'm going to put on the right hand side is going to be the leaf. So whatever the the rightmost number is. So in this case, 40, there's only one in the 40. So this is just going to be a 6, right? Then there's nothing else. Then 50, In the 50s, you see that there was nothing, there was no scores that were in the 50s, right? In the 60s, there was a 67, then after that, a 68, right? And then that's it. For the 70s, there was a 1, a 72, 272. So we're going to go ahead and write a 2 twice because there was 2 different 72s. Then we had a 74, we had a 75, and a 77. And for 80s, we had 81, 84, 85, 89. And then for 90s, we had 93, 94, and 95. And this is basically just what a stem plot is. So a stem plot basically gives you some sort of representation of the entire data. So you can look at this general shape. So if you kind of tilt your head a little bit, to the right, you can kind of see what it kind of looks like, right? So we will talk about the shape of the graphs in a little bit, but this is basically how you would draw a stem plot. It's usually called a stem and leaf plot also. So I'm going to write that down. So stem and leaf. Right, and that's basically what a stem plot is. So useful, but also, again, just for only small samples. You don't want to have a whole bunch of different samples and try to, you can, but there's other ways that you can do it. So, okay, and that brings us to our last type of plot. So I think it turned red, but okay, whatever. Okay, our last type of plot is what we call a histogram. So a histogram, basically what it is just grouped into bins. So what I wrote down here, what really a histogram is. So it tells you basically if you have a set of data, all it's just doing is grouping them into bins. So for example, what I have here is number of shoes, right, that students have, like males and females. So here what it says, if you own between 0 to 10 shoes, right, pairs of shoes, then this is where you're going to be at. You are going to lie in this, in here. So in this case, I think there was about 18 of them. So 18, this is the frequency, 18 people had between 0 to 10 number of shoes. So if you notice here, something that you have to be very careful with is looking at this. So this is frequency and this is relative frequency. So you have to be very careful with that. What frequency is just the number of people that we have within that particular category, right? So this is 18. Whereas here it tells you how frequent that was. So this was 18, right? So remember there was 18 people here, so there was 18. And then basically how you calculate the relative frequency, you take the number of people and then you divide it by the total. So in this case, it was actually 53. So you take 18 divided by 53, and what you end up getting is around 3.3 or something like that. So that's just basically what a histogram is. So you organize things into bins. Now, you don't really have to do this by hand. I'm not going to make you draw any of these graphs by hand, just simply because StatCrunch can just do everything for you. So, and I'm gonna give you data, and you're gonna go ahead and display it. But you don't really need to draw any of these. But you do need to know certain things about graphs and know how to read them. So in the next video, what I'm gonna do, I'm gonna go ahead and do examples using these types of graphs. So yeah, I think that was it that I was going to talk about. Yep, that should be it. All right.